Is now starting. All attendees are in listen-only mode.
Greetings, everyone, and welcome to our webinar. Today, we're going to be talking about MultiRegion Aurora from AWS, and we're going to compare that with Continuent Tungsten. And our goal is to build a geo-scale multi-region MySQL in the cloud. My name is Matthew Lang. I'm the Director of Professional Services with Continuent. And Continuent, we're a MySQL availability company. Just some housekeeping details. Feel free to download the handout that you can see on the GoToWebinar control panel. You'll see this presentation in PDF format. Download it and feel free to follow along or use it for later. And this webinar should last 30 minutes, and it's being recorded so you can watch it at your leisure as well. So just the agenda for this webinar. Again, my name is Matthew Lang with Continuent. We are the MySQL availability company, and this webinar is expected to last 30 minutes. And we're going to cover a few things. We're going to give an overview of Amazon Aurora cross-region. Then we're going to look at some challenges when using Amazon Aurora. Then we'll look at how can MySQL deployments be improved when we're talking about multi-region and high availability. And then if we have time, we'll do some Q&A. I'll be happy to answer your questions. As I said, this webinar is being recorded. So when we're talking about geo-scale MySQL, we're going to keep in mind some of the following goals that we have. So what do we need when we're deploying high availability MySQL? Well, the first thing is we need rapid failover in the local region or local cluster for high availability, and that should happen automatically. Okay, then we want geographically distributed clusters. So we want to be able to deploy clusters in various regions and have those clusters located closest to our users for the best user experience. We want to be able to use our read replicas or slaves for reads and have that automatically happen. We would like to be able to deploy masters in our clusters that are deployed across regions. Having masters in multiple locations gives the best performance for users closest to those regions. Ideally, we don't want to change our application code. Our applications have already been written, and we would like to just bolt a solution on without having to redo our applications. Then we want maximum uptime, and this includes when we're doing complex schema changes. Schema changes are one of those things where it's always kind of a thing we have to plan for and have a maintenance window for. So how can we make that better? And then finally, how can we avoid provider lock-in? We want to have access to our data, and we want to be able to take it wherever we want to. So just one other thing to mention, when we talk about MySQL for the purposes of this webinar and for Continuent, we're talking about any flavor of MySQL. So whether that's MySQL off the shelf from MySQL, MariaDB, or Percona Server. So let's talk a little bit about Aurora MultiRegion. And first, when we talk about Aurora, what really are the key benefits to Aurora? Well, Aurora is not MySQL. It's built from MySQL, but it is made to be MySQL 5.6 and to some extent 5.7 compatible. So it's a fully MySQL compatible database. Now on 5.7, there may be a couple things not implemented in Aurora, but as far as for basic day-to-day stuff, it's compatible. It supports read replicas. So you have a writer and you can create readers. So those readers could be failover candidates and we can read from them. It implements a distributed file system in the back end. So Aurora, all Aurora nodes, readers and writers, use this distributed file system in the back end. So, and that's how they get their read replicas. They do support cross-region replication using something similar to regular MySQL replication. And so that replication works within the framework of Amazon. It's possible to promote a remote read replica, that is a read replica in a different region, to become a standalone DB cluster. So what does that mean? If we have a read replica in a different region and our primary cluster goes down, we can fire up that read replica to become a read-write cluster. And then later on, we can rebuild our failed cluster from this newly stood up cluster. And then, of course, we all know that in some scenarios, it's actually pretty fast. And that is thanks to the distributed file system. Now, again, specific scenarios, some use cases will be faster than others. So what are the requirements then if we want to do multi-region Aurora? So we need to create a read replica in another region within AWS. So what do we need? Well, first we need a source Amazon cluster, right? Then we need to enable binary logging on that Aurora cluster. So it's not the same as enabling binlog on a regular MySQL database. There's a few settings you have to change. You have to create a new database parameter group to actually do this. Then in the target cluster or target region, we need a VPC. Within that VPC, we need a database subnet. So creating the VPC in a database subnet, that takes some planning, and you kind of have to get it right, otherwise you won't be able to create your read replica, and you'll be bouncing back and forth from your target region, reworking your network settings back to the source region to actually click on create read replica. So there's a lot of planning that has to go around that part. And then finally, your subnet in your target, you may want to make it accessible to the public. Otherwise, you won't be able to access your Aurora instance unless you have an instance that's local on that subnet. So again, there's definitely some planning with the networking required there. So after we do that, what are some of the limitations when using Aurora? Well, okay, we don't have Multimaster because master is in a single region. So we have a single master, and we can have this deployed. We can have read replicas deployed to different regions, but all of our writes have to go to that single master. So when we have a local failover, a failover within the Aurora cluster, our applications are going to get disconnected. Why are they going to get disconnected? Well, that's because even though the endpoint does not change, the DNS resolution behind that endpoint does in fact change. And so the only way to reconnect to the cluster after a failover is to have the application disconnect and reconnect. So that could potentially cause some serious errors on your application, and users may notice that. As far as the failover times, Amazon advertises about 1 minute for failover. In my testing on a very small database with just a few rows, it takes a little over 30 seconds for a failover. So 30 seconds may be a long time for your application, especially if it's an online application that's constantly taking traffic. 30 seconds could be a major outage. Okay, Aurora supports InnoDB only, which for most applications is fine. That's the most widely deployed MySQL database engine. However, there are other ones, and you may want to use other ones, or you may be using other ones already. There are even a lot of legacy MyICM tables out there. So in Aurora, you have to use InnoDB. To take advantage of reading from read replicas, your application has to know how to do this. So your read replicas have different endpoints. So to route a read to a read replica, your application has to know how to do this. So a lot of applications do not have that intelligence built in. Okay, all of our data in Aurora is, of course, in Amazon. It's going to stay there, and it takes some effort, actually quite a bit, to get it out. So now we are trusting Amazon with all of our data, with not a clean way to get it out. There will be periodic maintenance done by Amazon, which will cause outages. They can be limited to a maintenance window, but they will cause outages. And even though Aurora has support for some fast schema changes, even faster than regular MySQL, it's still going to cause outages for complex schema changes, even not so complex. Let's suppose you add a column with an initial value. On a large database, that's going to take quite a bit of time. And then this may or may not matter to you, but it is a proprietary system. It's not open source. It's not available for peer review. So what can we do to make this better? Well, again, let's review the webinar goals, because this is really what we want for multi-site, multi-master, geo-scale, and high availability. So local rapid failover. We want to be able to get a view of our cluster on a single pane. So we should be able to have one tool that's going to show us everything that's going on in our cluster at one time. We want to be able to read from our replicas. We want masters in all of our regions so we can deploy our application and databases close to our customers. We don't want to have to change our application code. Our applications are already written. We don't want to have to change them. We want this to be online, even during maintenance, even during complex schema changes. And we want to be able to place our MySQL database where we want to and not depend on a single provider. So with that in mind, let me introduce you to Tungsten clustering, because Tungsten clustering provides these services. We provide continuous MySQL operations. Again, zero downtime maintenance. We support Multimaster. We can be deployed in hybrid cloud. So you can have a deployment in Amazon, replicating to Google Cloud or on-site. We also include an intelligent MySQL proxy that we call the Tungsten connector, which you can see on this slide. It's actually deployed at the application stack, and it handles all of your read writes intelligently for you. So you do not have to change your application. We support all versions of MySQL, all flavors, and it's powered by the most advanced MySQL replication that we call Tungsten Replicator. And I'll get into all of that. But if we take a look at Multimaster, we can actually really easily construct multi-master topologies with Tungsten clustering with high availability at the local cluster level. So in this picture, we have two data centers. One could be Amazon. They both could be Amazon in different regions. One could be Google Cloud. We could have three data centers, one on-prem, Google Cloud, and another cloud provider, really wherever we want to. And in here, we have masters we're showing in both regions. So we can deploy clusters close to our customers. So our customers have the best experience for both reads and writes. That means the applications are responsive and the customer is satisfied with their experience. We can route users or route read requests to slaves for reading, and of course, writes go to the local master. So another topology we offer is very similar. We call it composite clustering. And this is where we deploy multiple clusters, but we retain just a single master. And for some customers, this works quite well because they want the simplicity of having a single master. So again, we deploy clusters close to our customers, or we would deploy it close to your customers. And all writes would go to that single master. However, reads, which are the most important when you're on a site for user experience, happen very quickly because they're reading from the slaves closest to them. In the event of a failover, where we're showing green this master, if this cluster were to fail, we can easily light up the slave data service to become the master. And that really just takes seconds. And now Our other cluster is the primary cluster. And the previous cluster, which had an issue, we can bring that back online after we've done all the hardware repair or whatever has to be done. We add it back into the composite cluster, and replication flows the other direction until it catches up. So we can easily fail over between one cluster and the other. So another thing that is important to us is zero downtime maintenance. Let's suppose we want to upgrade MySQL, or we need to patch the OS. We have a procedure to do that. And again, it's zero downtime. Why? Because we're able to upgrade the slaves at our leisure. And then when we're ready to upgrade the master, we actually promote one of the upgraded slaves to master. And we take that old master, and it's now a slave, and we upgrade that, and we're done with our upgrades. And we can also take this a step further for schema changes as well. So I'd like to summarize the key benefits of Continuent Tungsten when we're comparing to Aurora. So Continuent Tungsten supports all MySQL versions and flavors. So you are able to use the MySQL that you know and love, Percona Server, MariaDB, and whichever version you want to. Whatever data types you want to, it's all supported with Continuent Tungsten. So we both have read replicas, and we use our read replicas, we call them slaves. We can automatically direct read traffic to them, no changes to your application. And we can also fail over to these slaves very quickly, within seconds. And the other important piece is that your applications do not get disconnected in the event of a failover. That's very important. You don't need to restart your application just because your master failed. This is totally hands-off. This could happen in the middle of the night. No one, you do not need a person to actually do anything to make this happen. Okay, we use MySQL, regular MySQL. Again, the MySQL that you're used to, and it's deployed on the local file system the way you're used to deploying it. You have full access to the database and the file systems. We just bolt on top of it. We do cross-region replication, but not just within AWS. You can deploy clusters in AWS and deploy another region, say in Google Cloud, maybe several in AWS, Google Cloud, or on-prem. We are platform agnostic. You can deploy us wherever you would like to. And then again, zero downtime maintenance. You decide when you want to do your maintenance, and when you want to do your maintenance, you could do it all without taking your master offline. So lastly, and this picture may be a little small, but what this shows is our Tungsten dashboard. Our Tungsten dashboard lets you see everything in the cluster all on one page. So we're looking at a cluster here that's composed of several other clusters, but they're all replicating to each other. We can see each node, we can see the status, and we can do maintenance all on one single page. So we don't have to jump between region to region whenever we're doing some sort of maintenance, or we just want to have a look at our read replicas. It's all right here in front of us. So with all that, what we talked about, let me tell you who we are about Continuent. So Continuent, we are the MySQL availability company. We've been providing these solutions for years to hundreds of customers, and we enable our customers to run MySQL applications with zero downtime on a global scale, whether it's composite, production DR, or multi-site, multi-master. We support all clouds, hybrid clouds, VMs, or bare metal. You can deploy us wherever you want to. Our customers consist of SaaS, e-commerce, gaming companies, telcos, and even the Internet of Things. They rely on our software and process literally billions of transactions a day. And our software is entrusted to handle billions of dollars in revenue. And that's not an exaggeration. Our customers really do process this much data, and they trust us for their high availability needs. And then one of the best things about Continuent is we have a proven team with a minimum of 20 years of database experience per person. And you have access to our wealth of knowledge, to our team via our support, which is included, and it's 24/7 support. So let me talk a little bit more about our team, because we are really proud of our team. We've been doing this since 2004, and then kind of an interesting twist. In 2014, we were acquired by VMware. They had a project to introduce their own cloud offering that they called vCloud Air, and chose Continuent to develop their database as a service offering. In 2016, VMware reversed course and decided that they weren't going to be competitive with vCloud Air. So Continuent was spun off again, and we're continuing to do what we've been doing, providing high availability and zero downtime to MySQL. And stay tuned, because we're going to be launching a new product this year called Tungsten Cloud. And I'm not going to tell you too much about it, but definitely check out our website. We're posting updates there. And just to look at some of the companies that are using Continuent Tungsten, I'm sure you've heard of some of these companies before. Don't need to go into each one of these, but some pretty big names that are entrusting their data with Continuent. So we have two solutions I just like to mention. Tungsten clustering, which we've talked about, I've showed you. That's our high availability solution for MySQL. And Multimaster, disaster recovery, and geo-scaling. So you can deploy your solutions around the world, around the globe, around the country, and have your data local to your users. And then one of the pieces that powers Tungsten clustering is our Tungsten replicator, which we also have as a separate product, very widely deployed, and it's been out there for about 15 years. It's extremely mature. But not only does it replicate from MySQL to MySQL, but it replicates into a bunch of other targets. And let me just quickly show you some of those targets. So the Tungsten replicator can replicate into these targets. And so why would you use the Tungsten replicator? Well, if you need to do some analytics or BI, traditionally companies have used ETL, which when it works well is fine, but typically how that works is overnight you have a batch job that loads some data into a data warehouse, and then you go and you process and run analytics on yesterday's data. Any problem with the batch run overnight, you have to find out what the issue was and then restart it. But we're actually doing real-time replication. So when you're doing your analytics and using Tungsten for your real-time replication need, you're doing analytics up to the very minute. You have the freshest data. If there is any problem with replication, it's easily fixed, and then the Tungsten replicator just picks up where it left off. We can even replicate to, say, a Kafka bus, and then you can consume it however you'd like. So the key benefits of Tungsten. So it's MySQL, it's high availability in your local cluster and disaster recovery. We can fail over to your other sites. Again, your local failover is immediate, it's hands-off, it doesn't require anyone to do anything, and your applications stay connected, and that's due to our Tungsten connector. You saw the dashboard that I showed you. So one dashboard to see the whole cluster, to get the status of all nodes in all sites. So, and what do we mean when we say zero downtime? We can do maintenance without incurring downtime. we're compatible with all versions of MySQL. We can do cross-site failover as well. So if your primary data center has an issue, you can fail over within seconds your application to use your disaster recovery data center or whatever other data center you have. Okay. And of course, we support Multimaster, and we're really proud of this. We've been doing this for years. No one else does this, but deploy your clusters across the globe. And just like this picture shows, have your clusters local to your users for the best user experience and have masters in all regions. We cover the globe, and we are cloud agnostic or really platform agnostic. So deploy it in AWS and deploy another cluster that's replicating into Google Cloud or into your local environment or all three on VMs. We really don't care. We work everywhere and we support all clouds and local. And one thing that we provide is the intelligent MySQL proxy that we call the Tungsten connector. So with the Continuent Tungsten, you get the whole package. You get all your replication, you get all your clustering, and you get the Tungsten connector, which at the application layer directs traffic to the appropriate server. So we route writes to the master. We can route all reads to slaves. We can do that automatically without changing your application. Not only that, we can load balance on the slaves as well. If you have 4 slaves, we can just load balance between all of those slaves. And we have different algorithms for doing that. We also offer the Tungsten Replicator. It's the most advanced replication tool out there. You don't need ETL with the Tungsten Replicator. And Tungsten Replicator supports some really complex topologies like fan in and fan out, and we provide filters. So you can replicate certain schemas, certain databases, you can drop columns. So let's suppose you're replicating to your data warehouse. There are some columns that you may not want to replicate. So we can just filter those out and not replicate them. And again, geo-scale, high availability, and disaster recovery. Very simple administration. So how does this translate to the business? Well, there's a cost savings because you're using technology like MySQL that you already know. And you can deploy this where you want to. So you're not locked in to a particular vendor. If you want to run an AWS and have your backup in Google Cloud, great. If you decide that Google Cloud is going to work better for you, fine, just switch it over, not a problem. And the mundane tasks of recovery and site reliability, really, those tasks, we cover that. So your DBAs and admins don't have to spend so much time on those mundane tasks. All this without impacting or requiring a rewrite of your application. And by the way, we support SSL for all in-flight traffic. So whether that's connecting to the database, inter-database communication, replication, it can all be encrypted with SSL, which is really important for compliance and security. And then, of course, what we're most proud of, I made a separate slide for this, is our industry best 24/7 customer service. Our customers rave about this because we strive to provide the best support. Everyone on the staff is knowledgeable, is tier 3. If you have an urgent request, we typically respond within 5 minutes. So you know we've got your back. Any problems, you know that we're going to get back to you right away and get you back up and running. So just real quickly, recap. So we've talked about our support. We've talked about all this uptime, lower cost, total cost of ownership, and revenue protection. When your site is running, you can process transactions. If your site is down or has a blip, you're not processing. That could be detrimental to your business. That could be orders. So next steps, If you're interested in a demo, would like a POC, feel free to contact us at sales@continuent.com. And also feel free to look at we have a whole webinar library and training at our site. So feel free to have a look at it. And if you'd like to contact me or anyone else, feel free to reach out to anyone on this page. We'd be happy to answer your questions or arrange for POC. And we look forward to hearing from you. So now I'm going to click over here and answer any potential questions that you may have. So, okay, so we have a question. Are there large-scale customers right now using Tungsten Cluster in the cloud today? So yes, we actually have quite a few. So for instance, Samsung, the Artec division, is doing their Internet of Things all in cloud. And as a matter of fact, they migrated from RDS to Tungsten clustering using Multimaster. And they were able to get better performance using Tungsten clustering. So they have 2 sites, and again, masters in both sites replicating to each other. We have other customers too. Adobe is deployed in the cloud, and Modernizing Medicine is a healthcare company deployed exclusively in Amazon Cloud, and they're using a composite cluster technology. So it looks like I've run over time a little bit. I'd be happy to answer your questions offline. So with that in mind, if I didn't get to your questions, we will do our best to get back to you to answer them. Again, thank you so much for for coming to our webinar, and we hope to see you soon. And have a good day. Thank you.